Okay, go. That came out totally odd. But let's go ahead and finish up 7-5. Just a quick go back. Solving square root and other radical equations. So this is the second day of this particular lesson. Here we go. Example 4. Checking for extraneous solutions. Okay, the principle is the exact same thing. The only difference is now once you have your answers, you have to check and see if they work. Okay, so we've got the square root of x plus 2 minus 3 equals 2x. So we want to get this x plus 2 by itself, so we're going to add 3 to both sides. And remember, 2x and 3 are not like terms, therefore they cannot be combined into one single term. So we have the square root of x plus 2 equals 2x plus 3. Now we need to do the opposite square root because we're trying to solve it for x. So the, excuse me, the next thing we're going to do is square both sides because that is the inverse operation of a square root. So this cancels out and we are left with x plus 2 equals, and we're going to use that binomial square property. And again, just write that off to the side. A plus b squared is equal to a squared plus 2ab plus b squared. First term squared is going to be 4x squared, 2ab, so I'm going to multiply these two together and double it. 2x times 3 is 6x. 6x times 2 is 12x. 3 squared is 9. Okay, so now we have x plus 2 equals 4x squared plus 12x plus 9. We need to get all of the terms, excuse me, on one side. We need to solve this for 0. So I am going to leave the 4x squared plus 12x plus 9 on the right, and I am going to subtract x from both sides, and I'm also going to subtract 2 from both sides. Now this leaves me with 0 on this side. X minus x is 0, 2 minus 2 is 0. On the right, we have 4x squared. 12x minus x is 11x. 9 minus 2 is 7. Now we have two possible directions to go in at this point, and that's either to factor, excuse me, or use the quadratic formula. Now in class I showed you the, I believe I showed you the factoring method, so let's go ahead and do the quadratic formula. Because this is already written out, I'm just going to put the a underneath the 4, b underneath the 11, and the c underneath the 7. Just a quick review: quadratic formula, negative b plus or minus square root of b squared minus 4ac all over, wow, whoops, 2a. Okay, so coming over here, x is negative b, so negative 11, plus or minus the square root of 11 squared, which is 121, minus 4 times a, and a is 4, and c is 7, all over 2 times 4. Excuse me. So now we need to clean things up, if you will. 4 times 4 is 16. 16 times 7. I already know this just because we've done it so many times, but that's okay. 16 times 7, 6 times 7 is 2. Carry the 4. 7 times 1 is 7. 7 plus 4 is 112. So this becomes 112. Okay, so now we have negative 11, excuse me, plus or minus 121 minus 112. 121 minus 12 is going to give us the square root of 9. And then this is all over 2 times 4, which is 8. Square root of 9 is 3. So now we have negative 11 plus or minus 3 all over 8. Excuse me. Negative 11 plus 3, because we're going to have two separate answers because it's plus or minus. So we have negative 11 plus 3 over 8, or we have negative 11 minus 3 over 8. Negative 11 plus 3 is negative 8. Negative 11 minus 3 is negative 14. Negative 8 over 8 is the same as negative 1. Negative 14 over 8 is the same as negative 7 fourths. Okay, so now we have found both answers, but are these viable solutions to this equation? Because of this statement here, but regardless, we definitely want to check for extraneous solutions, okay? If you are instructed to, you definitely have to. So we need to check and see if, let me go down here. Bring that equation down here. So we've got the square root of x plus 2 minus 3. Is that right? Holy cow. The square root of x plus 2 minus 3 equals 2x. Okay, I want to rewrite this so it's just a little bit cleaner. So we have square root of x plus 2 minus 3 equals 2x. Okay, so now we need to check. So checking negative 1, we have the square root of negative 1 plus 2 minus 3 equals 2x. 2 minus 1 is 1. So now we have the square root of 1 minus 3. The square root of 1 is 1. 1 minus 3 is negative 2. 2 times x is negative 1. 2 times negative 1 is negative 2. Does this match? It sure does. So therefore, negative 1 is a solution. All right, now let's test negative 7 fourths. I think I like the term test better than check. Negative 7 fourths goes in for the x. So now we have square root of negative 7 fourths plus 2. Don't know why I get so crazy with this radical symbol. Minus 3. And does it equal 2 times, I'm going to go ahead and put the negative 7 fourths in. Whoops, not what I wanted to do. Okay, let's put that question mark there. All right, negative 7 fourths plus 2 is 0.25. So this gives us 0.25 underneath there. The square root of 0.25 is 0.5. So now we have 0.5 minus 3. Does it equal, let's see, 2 goes into 4 2 times and goes into itself once. So now we have negative 7 over 2, which is the same as negative 3.5. 0.5 minus 3 is negative 2.5. Does negative 2.5 equal negative 3.5? Obviously not. So this is not a solution. So the only solution we have to this problem, and yes, I realize how horribly long this is negative 1. Okay? All right. Now, final example that we have, solving equations with two rational exponents. Joy, oh joy, oh joy, right? Okay, so similar setup. We want to make sure that we have the radical expressions isolated. So therefore, we are going to add 9x plus 1 to the 1/3 to both sides. This cancels out on the left, and we're left with x plus 1 raised to the 2/3 equals 9x plus 1 raised to the 1/3. Okay, now we want to look at this denominator, okay, of the rational exponent. We want to get rid of the fractional exponent. I hated fractions as a kiddo, so I understand. To clear out the 3's, we're going to raise both sides to the power of 3, and therefore it will cancel out. Okay, so raising this to the power of 3, it cancels out the denominator. So now on the left, we have the expression x plus 1 raised to the power of 2 squared equals 9x plus 1 expression raised to the first power, which is just 9x plus 1. So we're not going to worry about putting that in parentheses and raising it to the power of 1. Now, just like we did in example 2, I believe it was, we are going to do the a plus b quantity squared is equal to a squared plus 2ab plus b squared. This binomial square property states you square the first, you multiply the 2 together and double it, and then you square the last. Excuse me. So on the left side, first term squared, x squared. Multiply these two together, we get x. Times 2 is 2x. Last term squared is 1. And now we have this is equal to 9x plus 1. X squared plus 2x plus 1. I am going to choose to leave the equation on the left side. So let's subtract 9x from both sides, and let's subtract 1 from both sides. I suppose I should hurry because the battery's about ready to die. Okay, so we're going to have x squared. 2x minus 9x is negative 7x. 1 minus 1 cancels out. 9x minus 9x is 0. 1 minus 1 is 0. So now we have x squared minus 7x equals 0. Well, I just love to see this because x squared and 7x both have x in them. So let's factor out an x, and we're left with x minus 7. So now we have x times the expression x minus 7 has to equal 0. So either x equals 0 or x minus 7 equals 0. So we add 7. And either x equals 0 or x equals 7. Now, of course, we do need to check these because we could possibly have an extraneous solution, especially as stated up here in the original directions. Check for extraneous solutions. Alright, so coming down here, writing this down. I'm going to put it right here. X plus 1 raised to the 2/3 minus 9x plus 1 raised to the 1/3 equals 0. Okay, so this is, I'm pointing at it as if you guys can see me pointing it. This is the original equation, so we need to test x is 0 and we need to test x is 7. So testing x is 0. 0 plus 1, right? Because we plug in 0 for the x. 0 plus 1 raised to 2/3 minus 9 times 0 plus 1 raised to the 1/3. Does that equal 0? 0 plus 1 is 1. 1 raised to anything is 1. 1 minus 9 times 0 is 0. 0 plus 1 is 1. Again, 1 raised to the power of anything is 1. Does 1 minus 1 equal 0? It sure does. So this is a solution. Now plugging in 7, I'm going to change to green just so we can differentiate between the two. 7 plus 1 raised to the 2/3 minus 9 times 7, right? 9 times 7 plus 1 raised to the 1/3. Does that equal 0? All right, so 7 plus 1 is 8. 8 raised to the 2/3 is going to give us 4 minus 9 times 7 is 63. 63 plus 1 is 64. The cubic root, right? The cubic root of 64 is 4. Does 4 minus 4 equal 0? It sure does. So 7 is also a solution. Now, I just did some of this mentally, but I would highly encourage, if you're not there yet, to use that calculator to kind of help you along. But I would also encourage you to work on doing that mentally, because that's going to help strengthen those skills, and it's kind of like Olympics, math aerobics, brain aerobics. Okay, so that's it. If you have any questions, you know where to find me.